Welcome to TurboCams 101, presented by Comp Cams, the absolute leader in Valvetrain technology. Today, we're going to dive into the science of creating a camshaft optimized for turbo applications. To understand the camshaft needs of a turbocharged engine, we have to look at how air and exhaust flow through the cylinder, how back pressure affects this flow, and how the intake and exhaust cam profiles and valve event timing should be used to control it. In a naturally aspirated engine, pressure on both the intake and exhaust sides of the cylinder will be close to the ambient atmosphere, or a pressure ratio near 1:1.
Normally aspirated motors have 1 atmosphere pressure in the inlet, 1 atmosphere pressure in the exhaust, and we create all the motion of flow by either piston motion or wave tuning.
Add an engine-driven supercharger, and the pressure ratio changes in favor of the intake side, which may have 2, 3, or even more atmospheres of pressure, while the exhaust remains close to ambient.
Now we're driving air in with some sort of compressor. So we have the higher pressure in the inlet system and lower pressure in the exhaust. So we can use that to initiate airflow even before the piston starts moving away from top dead center.
Turbocharged engines also raise intake pressure above ambient, but the restriction caused by the turbine wheel driving the compressor causes back pressure in the exhaust, changing the pressure ratio and affecting cylinder filling. Older, inefficient turbocharger systems might see twice as much pressure on the exhaust side as the intake, leading to extreme challenges in camshaft design.
In those applications, we have to be really careful about overlap, because if we open the intake too soon, then while the exhaust is still opening, the pressure differential will cause a backflow. Sometimes you'll see people where they'll go and do a turbocharged application, high back pressure, and put an NA style camshaft in, and there'll be so much flow of burnt exhaust into the intake manifold that you'll see brown or black charred into the intake manifold. Once we understand what's going on the turbine side with the boost, once we understand what's going on with temperature side, once we look at the pressure on the exhaust side with the exhaust back pressure, then we can really help you optimize your valve timing for your application.
Modern, efficient turbocharger designs are far less restrictive on the exhaust side and have a pressure ratio closer to a naturally aspirated engine's 1:1. But pressure isn't the whole story.
Now, instead of dealing with high pressure, low pressure, we're dealing with the elevated pressure on both sides, high density on both sides, and we're back into more of a system that's working like normally aspirated, using the piston motion, using some wave tuning to create the mass flow through the system, but at lower velocity and less valve timing.
While every turbocharged engine combination is unique, based on what we've just learned, there are some general rules that apply to a camshaft grind designed to work with a turbo. For cam grind recommendations personalized for your own turbocharged engine, consult directly with the Valvetrain technology experts at Comp Cams at 800-999-0853 or online at compcams.com.